Hello, my name is Jemariah Valencia, and the public lecture that I attended and enjoyed the most was about the cosmic rays with the speaker, Dr. Oat. So basically, his main thesis in this lecture was explaining or asking us where do cosmic rays come from, and he emphasized that they are not the same death rays that we see in the movies, and I thought that was pretty interesting. Because cosmic rays don't harm humans instantaneously. Some background history that I had to kind of Google because he didn't really go in depth was about Professor Victor Hess. He discovered the cosmic rays in 1912, and based on what I found online, the balloon flight that Professor Hess took in 1912. Well, there were a couple balloon flights that he took, but he had electroscopes with him and gamma ray detectors, and basically he found that with higher altitude comes with more ions or gamma ray ions. And basically the values at the greatest altitude that he was able to go on had 22 to 24 more ions, higher than the number of ions on ground. So basically that's when he found that cosmic rays do exist. And 1931, while he was a professor at Innsbruck University, he founded a station near the Hafellakar mountain where he did further observation and research on cosmic rays that he found that he knew existed. Then in 1936, he won the Nobel Prize for this, and since then, and even before this time, he's published books and papers about cosmic rays and basic and electricity in the atmosphere. Some of the things that I already knew before coming into this lecture was some of radiation's everyday applications, such as in radiocarbon dating using carbon-14, and how radiation can affect electronics. But I didn't know that radiation can be possible seeds for lightning when there's enough pressure and ions between the clouds and the atmosphere. So that was pretty interesting. And I also learned that cosmic rays specifically are dispersed as soon as it enters the atmosphere. And with this, Dr. Oat showed a graph called the Earth frame particle graph, which basically shows the number of particles that reach the ground or different altitudes of Earth, and there's significantly less particles that reach the actual ground than what enters in because it's scattered so much. And to the right of this slide is a cosmic ray spectrum, and as you can see, most of the particles are protons. And one thing interesting about this spectrum is that it can measure and trace the direction of the cosmic rays. And basically in the lecture he talked about the different ways that people have tried to measure where this cosmic ray is coming from. And so from what I understood, there were different particles that different scientists have looked at and tried to use to trace the origin. So they've tried using the proton emitted, the neutrinos, the pi naughts, and the gamma particles emitted from the cosmic ray. But a couple of problems arose with each particle. So the problem with the proton is that it's charged. And so this could be easily deflected by anything in the atmosphere or outside of Earth containing magnetic field, etc. In the neutrino, Professor Oat discussed the ice cube neutrino detector that someone has used in this near the southern hemisphere, and it detects neutrinos with a large surface area, but it has no evidence of point sources, and you need a lot of volume to catch a neutrino under the ice. And in order to be more accurate, you would need a larger detector to be more certain of the origin. And the pine knots, one couple problems about it, or a couple good things about it, is that it has no charge, so it can't be deflected or influenced by any magnetic or electric field outside. It is a direct source to us. However, it is short-lived, and there are no thermal waves detected, so it's kind of hard to use that, I think, or what I concluded. And some gamma particles, he mentioned the electromagnetic spectrum, and he showed us a picture of the universal optical picture versus the gamma rays non-thermal picture, and you can see that towards the center of the Milky Way, that's where most of the gamma rays are coming from. He also talked about many cosmic ray accelerators, which basically promote the cosmic rays. And he talked about neutron stars, gamma ray bursts, black hole, supernova remnants, like the Jellyfish Nebula, and starburst galaxy, or the starbursts, and also pulsars. And he said that pulsars are a good source of relativistic electrons. Yeah, so these are just some of the pictures that he had on his slide. And one of the fundamental physics law that we talked about was the speed of light is constant, 3 times 10 to the 8th. And also he kind of hinted at a future project that people might be interested in, which is in order to detect and be more accurate with the origin of cosmic rays, we would need to build a different type of equipment with higher sensitivity to these particles. Large array of telescopes covering a large surface area, and he's also doing a project currently in the physics department, working with fixing the camera that he already has. And in the end of the lecture, he took out 2 paddles that are cosmic ray detectors, and he basically let us hear the particles coming down and on the paddles. So that was pretty interesting. And that's it. Thank you.